Welcome to 5G Hub. In this video, we will talk about uplink enhancement technology in 5G. With higher capacity, better reliability, and lower latency like no previous generations of mobile technologies ever before, 5G can meet the growing demands for mobile internet and also help modernize a lot of vertical industries such as manufacturing, transportation, energy, and healthcare. As 5G is becoming integrated literally into every aspect of our society, the huge variety of its application, including the Internet of Things, cloud storage, high definition live streaming, etc., calls for outstanding 5G performance, particularly in uplink capacity and coverage. The most popular 5G bands in the world are TDD new radio bands such as 3.5 GHz and 2.6 GHz, which do offer very large bandwidths around 100 MHz and therefore high capacity, but can be underperforming in terms of uplink coverage and capacity due to the limitation of mid bands and TDD duplex technology. It's therefore very important for 5G to improve the performance of uplink in order to realize the potentials of 5G in more applications, better user experience, and lower deployment cost. If we are talking about uplink performance, 5G network initially focuses on enhanced mobile broadband, while with 5G large-scale commercialization, operators would turn more of their attention to opportunities in business-to-business markets. Regarding to uplink data-intensive applications, the top quality 5G network should accommodate massive data capacity requirement on the uplink, including HD or high definition video, online games, big data collection, intelligent surveillance, AR, VR live video, which demands continuous improvement of network capacity and latency. Now let's discuss about 3GPP efforts regarding 5G uplink enhancement technologies. 3GPP has been focusing on the uplink enhanced technology in the 5G new radio standards. There are three uplink enhancement technologies in 3GPP release 15. ENDC or EUTRA new radio dual connectivity. Second one is carrier aggregation. Third one is supplementary uplink. And in 3GPP release 16, uplink transmission switching is introduced as a new feature to enhance ENDC, CA, and SUL. Now we will focus in this video about 5G dual connectivity performance analysis. For example, here, when radio access network or RAN is composed of E node Bs as a master node and G node Bs as a secondary node, it's called ENDC or EUTRA new radio dual connectivity. With ENDC, UE or user equipment can transmit data under only LTE or under both LTE and new radio coverage. Therefore, the coverage problem of the users at the edge of the cell can be well solved. Here we can see the analysis of ENDC. Due to the difference between 4G, as we can see here, between 4G and 5G coverage, the applicable scenario of ENDC are shown in the following. In the area A, because there are both 4G and 5G coverage, user equipment capable of ENDC can transmit data by 4G and 5G at the same time. As a commercial terminal generally supports two transmission channels or 2TX, for example, one TX can be used for LTE and the other for 5G NR. However, in area B, You can see here only 5G is available in downlink and 4G available on uplink and the downlink. Because there is only 4G coverage, user equipment can only transmit data through 4G or LTE. In area without 5G coverage, LTE is used to send the data in the uplink. So, although the uplink coverage of 5G is not actually improved, the coverage area from the user perspective is extended here. In general, with NSA architecture, 5G uplink throughput is improved compared with 4G, yet still lower than 5G standalone for sure. The coverage of 5G new radio is not improved, but in areas without 5G coverage, where both signaling and the traffic can be transmitted over 4G, user experience is not deteriorated compared to that of 4G network, for example. So here, this is the first step or the first feature of 3GPP release 15 about how to enhance the 5G uplink or the user equipment UE experience in the uplink. This analysis is based on ZTE vendor. So this is for today, and thank you for watching, and see you in the next video.